line y equals 5 is a horizontal asymptote to the graph of which of the following functions? So if we have a horizontal asymptote on a graph at y equals 5, then that means if there is a graph, as the graph gets closer to the horizontal asymptote, the graph must approach infinity, because the graph cannot cross the horizontal asymptote, but it can get closer and closer to it. So that means if we take the limit as x approaches infinity, so infinity somewhere over here, of one of these functions f of x, then the limit should tend towards infinity, or sorry, if we take the limit as x approaches infinity of one of these functions f of x, then the graph should approach the value 5, because the y value of this asymptote is 5. And graphs can get closer and closer to the asymptote, but they will never touch it or cross it. So we will approach 5 as x approaches infinity. So we can just take the limit of all of these answer choices and see which one approaches 5. So for A, if we take the limit as x approaches infinity of sine of 5x over x. So if we were to plug in infinity into sine x, we know that sine x is an oscillating function. In this case here, it would oscillate between 1 and -1. So we know that as x approaches infinity, this limit is undefined, because the sine function doesn't converge to any value. It just oscillates between two values. So the limit as x approaches infinity of sine x, or sine of 5x, is undefined. So A cannot be the correct answer. And then what about B? As the limit as x approaches infinity of y equals 5x. If we plug in infinity for x, then we're just going to get infinity, because as we know in the xy plane, y equals 5x is just a increasing, or a linear line with a positive slope. So as x goes to infinity, this function will just keep growing without bound. So this doesn't converge anywhere. So B cannot be correct. Okay, C, if the limit as x approaches infinity of 1 over x minus 5. So here, if we plug in infinity for x, we'll have a rational function where we're dividing by infinity. So this just evaluates to 0. So C cannot be correct. For D, we take the limit as x approaches infinity of 5x over 1 minus x. In this case, we're going to have an infinity in the numerator and infinity in the denominator. And infinity over infinity is an undeterminate form. So what we can do is use L'Hopital's rule and take the derivative of the numerator and denominator. So we'll have limit as x approaches infinity of 5 over -1. And so this just evaluates to -5. So what this is telling us is that this function, after applying L'Hopital's rule, since in this form it's indeterminate, that the function approaches -5 as x approaches infinity. So that means this function cannot have a horizontal asymptote at y equals 5, because it approaches -5 instead. Okay, and then what about answer choice D? the limit as x approaches infinity of 20x squared minus x over 1 plus 4x squared. So in this case, let's do some factoring to simplify. So we'll take an x common out in the numerator. So we'll have 20x minus 1. And then in the denominator, we'll just have 1 plus 4x squared. So again, if we plug in infinity, we'll have an indeterminate form because we're going to have infinity over infinity. These functions both grow without bound. So let's apply L'Hopital's rule. So let's take the derivative of the numerator and denominator. So we'll be left with the limit as x approaches infinity. We'll actually use this up here to take the derivative. So we'll have 40x minus 1 over 1 plus 8x. And again, if we tried to plug in infinity into the x's, we'll still have an infinity over infinity because these functions both grow without bound. They are linear increasing functions. So we can just apply L'Hopital's rule again and take the derivative of the numerator and denominator. Then this time we'll be left with 40 over 9 or 40 over 8, since the derivative of 40x is just 40 and the derivative of 8x is just 8. Now, since there are no more x's, this is just the limit of a constant, and 40 over 8 is just equal to 5. So that means for this function in in E, as x approaches infinity, the limit of the function approaches 5. So that means this does approach an asymptote at y equals 5. So E is the correct answer.